Hi everyone, in this video lesson we are going to speak about routing concepts. First of all, before starting this lecture, let's take a look for the scenario in which we have the map of the world and in which we have the situation that we have 2 points, point A, which is placed in Almaty, and point B, which is placed in Rome, Italy. So in case if we want to go from point A to point B, we are able to travel by the multiple different passes or different roads. And actually this screenshot I took from the Google Maps, and it's showing me actually three variants. The best variant is labeled with the blue marker, and the rest two of them are labeled with the gray marker, so that the best pass is like this. Okay, so if I'll travel by my car, so it will take about 83 hours, and it's going to take about 6,000 kilometers. So we have also second variant through the Moscow, and the third variant through the Turkey. So we have actually much more passes than we see it in this screen, because you can go actually through China, Pakistan, Iran, and even you can go through the Africa, and afterward you can sit on the boat and go like this from the Tunis, or you can go through the Mongolia and come back again from the USA and reach the Italy. So we have a lot of variants. We have a number of variants of passes, but someone gives us these passes. In the case when we look for the example like this in the map, so we have a navigator. A navigator gives us the recommendations: go to the left, go to the right, and so on. So in network worlds, in each of these crossroads, when we have the variant, for example, we have the variant on the crossroad. We travel from the left side to the right side, and we have variant 1 and variant 2 to travel to, for example, point B. And when we come to this crossroad, in the crossroad we have a device which is called the router. Router asks from us, where are you going to, what is your destination? And afterward, we as a packet will say that I'm going to point B, and then router will make decision to switch you to this port, or maybe by using this port. And all decisions are done by the separate routers, so that every router gets its own routing table by which the router can able to define the path for the packet, so that it will reach successfully the destination. Alright, let's take a look for the routers in the action. So here we have three networks, network 1, 2, and 3, and we have interconnection between them by using two routers. And when computer sends information from one network to another network, it's going to reach the router. And when router reach the packet, router get the question, where are you going? And in the packet we have the information that that packet goes to network 3, and afterward router will immediately take a look for its own routing table. And as you see here, we have the comment in the CLI which will show you the routing table, which is looking like show IP route. So let me just mark it. So here it is. So by using this command you are able to see the routing table, and in routing table we have network 30, which is going to be our destination, and router 1 will send it to next hop IP address is 2 and 2, and the owner of this IP address is router 2 and 2, so that our packet is going to be sent to the router 2. I heard this. Router maps the destination IP address with the routing table, and afterward resend it to router 2. And in this case, router 2 will also take a look for the routing table, and it will find that the pass for this network, I mean network 300, is directly connected through the interface FA00, so that we have interface FA00, and it means that router 2 is going to resend this packet out of this interface, through this interface. Now here it is. Routers are using the routing table to define where to resend the information. Let's continue with you. We have three mechanisms of the packet forwarding. They are the process switching, the fast switching, and Cisco Express forwarding. So if we'll compare them, the slowest one is the process switching. It means that every packet, when the packet comes to the router have to make research for each of this packet where to resend this packet. So our request will go till the CPU, and CPU will make operations as you saw before, so that the CPU will map the routing table with destination IP address, and after making decision, router will resend the information through the outgoing interface. So also we have the fast switching, which is doing absolutely the same thing for first packet. The first packet comes to the router makes the processing. So this is routing process. Router finds through which interface router has to resend the packet, and afterward it is resending first packet, and all other packages which are coming right after the first packet will go through the fast forward cache, so that the processor, the CPU, will not be impacted after the first packet. That is why it is called the fast switching. And also we have the CEF, the Cisco Express forwarding, and this type is the fastest one. This actually builds the forwarding information base and an adjacency table of the routers. And in comparison between fast switching and Cisco Express forwarding, the difference between them, that the Cisco Express forwarding prepares all the passes. I mean, it prepares all the exit interfaces before packages will come. And when packet will come to any direction which is known by the router immediately is able to just resend this information without making this research, or where to resend this packet, and how to find the exit interface, and so on. So we have three mechanisms of the packet forwarding. Now it's time to take a look for basic configurations of the router. So in this case, I have to show you how to make configuration of the host name, the passwords, some multiple passwords for different the modes of in the router, the banner of the message of the day. And I have to also show you how to make configuration of IP addresses of IP version 4 for interfaces and IP version 6 for interfaces. And also I'll show you what is loopback interface and how to configure it. Let's start with the packet tracer example. In packet tracer, I prepared one packet tracer file here. So we have the router. So the router is placed in network device and routers, and I recommend you to pick up the router 2911. So let's come closer to this router. And if you click to the router, you will see its physical view. So in the physical view, you may find out that the router consists of some interfaces, including gigabit 0000102 interfaces, which are used to make which are used to interconnect the Ethernet networks. And we also have the console lines, which are used to make configuration. Mostly it is used to make initial configurations of the router or the switch, if it is switch. Also, we have auxiliary port, which is used to manage the device like a console, but by using the dial-up modems, and some USB ports. Also, you may see here that here is the switch turn on and turn off. So if you click like this, it is turned off, and if you click one more time to this button, it is turned on. And we have two slots for the flash memory cards, and we have some slots for the additional models of the router. Um, so this router is called ICE. The type of the router is the ISR router, integrated service router, so that it can provide integrated services for us, for the network. So I recommend you to firstly to turn off the router, and afterward I recommend you to place HVIC 2T model, which is the model that uses to interconnect routers by the WAN and provides two serial ports. It will be quite enough for our example to place one of them, but you can place four of them in a row. And let's turn on the router. Right after you click it to the button turn on the router, you may see that your router is loading the operating system, and it asks you the first question. The first question is like, would you like to configure the initial configurations? So I recommend you to type no, because in case if you are selecting yes, then the router will ask you too much questions which are not belong to our practice. So first of all, let me show you how to make configuration of the router name. So router name have to be configured on the router due to that fact that routers have to be distinguished by the names according to the position which router is in which router is placed, and the work type which is a router is doing. First of all, you have to go to the privileged executive mode. Afterward, you have to penetrate into the global configuration mode. And in global configuration mode, you have to type the common host name. And for example, it's going to be a router. So let's say it's going to be router 100 or router 11, let's say. And as you see, so after you change it, the host name, immediately you can find out that the router, which been called router before, now is called R11. But here in display you may see that its name is router 0. So if you want to change also the display name, you have to click to the router, you have to go to config, and you have to change the display name right from here. So R11, oh sorry. And afterwards let's continue with you. First job is done, so we configured the host name. Now let me show you how to make a configuration of the passwords. When someone will try to have access by the console line, like we did it right now. So for example, if we'll exit the session, and if I'll try to make configuration, so I already have this ability to do it. Now I'm in console line configuration in the user executive mode. And to protect your user executive mode and console line, you have to go to line configuration, so line console. Due to that fact that we have a single line console, it has the sequence number 0, so that you have to just type line console 0. Afterward, inside the line console, you have to type the password, and the password is going to be Cisco. And also you have to provide information, like you have to type login. Why you type login? When you type login, you say that, look, this Cisco router will use exactly this password which we provided right in this console line, because we may have different variants of the username and passwords, and if you want to use exactly this password which is configured right on this console line, then you have to provide the login command. So in case if you will not provide this information, then your router will not ask the password. Okay, then let's try to exit one more time, and now it's asking me the password, which is the Cisco. By the way, when you type the password, so for example, now I'm typing Cisco as a password, and it is not showing me any symbols. It's also the security purposes, so that do not surprise that when you you type and it's not showing you any characters, any stars or dots, don't be surprised and continue. Alright, now the first password was given to console line. Another password I want to give to protect my privileged executive mode. To protect privileged executive mode, you have to go to global configuration mode, and in global configuration mode you just have to type enable password. So if you'll provide this password like enable password class, then let's exit one more time. So it's asking first password, which is just the Cisco. It's the password for a console line. And when I'll try to be connected to the privileged executive mode, it is going to be ask me the password for the privileged executive mode. It is class. Alright. Now, if I'll take a look for my running configuration file, which is stored in NVRAM memory, I can easily find that I have the line console password Cisco, and that my privileged executive mode's password is have to be placed right here. So it is the class, and all the passwords are seen in the plain text, and it's not so good idea to store them in running configuration file in this view. So to encrypt your passwords, you can use the service password encryption, which will encrypt all existing passwords and all the passwords which will be configured in the future. So that if you'll type now show running configuration file, you may see that your password is encrypted. The first password is encrypted, and the last password is also encrypted. Well, the second step is also done. I showed you how to make a basic configuration of the passwords, and we have the next thing is the banner message of the day. When someone will try to be connected to the router and will exit, for example, and try to be connected, so that here we have user access verification. This is just the text, and you also can provide your own text, like authorized access only or something like this. So that let me go to the global configuration mode, and afterward I have to just need to make such kind of thing like banner MOTD, and afterward I have to place my banner between this characters, and it's going to be, for example, authorized access only. And now if I'll try to access the router, it is saying that like warning, authorized access only. So you have to say to the people who are trying to break your router, or who tries to be connected to this device to manage it, you have to firstly mention that person that is not allowed. It's like unauthorized access is prohibited, and so on. Alright, the third part is done, and now let me show you how to make configuration of the interfaces with IP version 4 addresses. The first job what you have to do, you have to take a look or what kind of interfaces do you have in this router. So to see all of your interface with the brief information in a very small table, you have to type the command show IP interface brief. So this command will show you the report with the IP addresses of all interfaces which you have in this router. And for example, here we have gigabit 00, 01, 02, and I have two serial interfaces which I added with you for this router. And we can see that we don't have any IP addresses, and we can see that we have the status of the interface is the administratively down. So that to turn on your interface, you have to go to interface, and by the way, all of the interfaces of routers are turned off by default, and in comparison with the switch ports, all of the switch ports are turned on by default. So that by default all of the interfaces of router turn off, and that is why you have to with those interfaces with which you want to work, you have to turn on that interfaces. So from the global configuration mode, you'll type the command interface gigabit 00. And for example, you will turn on this interface by using the command no shutdown. And if you want to shut down, if you want to turn off this interface, so shut down. If you want to turn on this interface, you will type no shutdown, or you can use the abbreviations like no sh. And afterward, to take a look for your brief table of the IP addresses with interfaces. And if you do not want to exit from this mode to continue to configure your interface to the privileged executive mode, then you are able to use the command do. Do command is taking the priority of the privileged executive mode, so that now you are able to type the command show IP interface brief. But in case when you are using do command to use the privileged executive mode's privileges, then you are not able to see the hints like you saw them in the privileged executive mode. So that you just have to know what command you have to type. And now you may see that status is up. It means that our interface physically is turned on, but the protocol is not working. It means that we have to be connected from this router with the interface gigabit 00 to any other device which is properly working. So let me be connected from router to the switch by using gigabit 00 port, and the cable is going to be UTP race row cable. And for example, I will be connected to fast 00. And as you see, after I made up the connectivity from router's interface to switch interface, which is actually starting to work, or we may say it is a working switch port, we may see here the output which is generated by the router, and router say that, alright, line protocol on interface gigabit 00 changes state to up, and it means that if you'll take a look one more time for this small table, you will see that now protocol is turned on and it's already working, but we don't have an IP address. How to provide an IP address for the interface? First of all, let me place some nodes for the router's interface gigabit 00. Let me say that this IP address is going to be 10 and 11 with the prefix of the 24. And you know that if our prefix is 24, then subnet mask is going to be in binary is going to be looking like this. We have 8 bits: 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, and 1 2 3 4 5 6 7 8. So in this binary string we may see 24 bits from the left side, which are placed with ones. So, and in case if you will convert this ones and zeros, I mean binary string, into the decimal, you will see 255, 255, 255, and 255 as and 0 at the end as the subnet mask. So when you have prefix 24, then your subnet mask is 255, 255, 255, and 0. Now it's time to make configuration of our interface with proper IP address. Let's do it. I have to be inside the interface gigabit 00. Be sure that you are in the mode of the interface by using this hint, like if it is interface. And let me type the command IP address 192.168.10.11 with prefix with subnet mask of prefix 24, like this. So that now let me try to check do I have a proper configuration of my IP address or not, so I can see it from here. See, but I don't have any information about the subnet mask or the prefix, so that is why you are able to type the command do show run, and so let's take a look. So here it is. This is our subnet mask. So in case if you want to see detailed information about the interface, you can type the command show interface gigabit 00, and it will show you the full information about this interface. Gigabit 00 is turned on and the line protocol is up and it is connected. Its MAC address is looking like this. Its IP address is configured like this, and you see it has the prefix 24, but we didn't give the information about prefix. We just made up configuration of the subnet mask. Alright, now we know how to make the configuration of the interfaces with IP version 4. Now it's time to make configuration of interfaces with IP version 6 address. And in our example, we are going to have an IP address on the same interface. Actually, we may provide IP version 4 and IP version 6 addresses. As an example, we'll have with you such kind of IP address with prefix 64. And how to make configuration of the router's interface with this IP version 4 address. First of all, I recommend you to go to global configuration mode and type the command IP version 6 unicast routing. This command turns on the functionality of IP version 6 on the router, because by default router is not working with IP version 6 routing. And afterward, you will go to configure the interface gigabit 00, and you already know that it's turned on by using this the green colored blinking lamp. So that you don't need to type now no shutdown because it's already turned on, and now you have to just provide IP version 6 configuration. So you just write IP version 6 address and 2001 :1 with prefix 64. It's pretty nice to configure IP version 6 because you don't have to make calculation of the subnet mask. You just need to know the prefix. And now we have an IP address which is looking like this. And if you want to see the output of your router's interfaces with IP version 6 addresses, then you have to type the command like do show IP. Previously you typed do show IP interface brief, but now you have to just add to this command version 6 to see all IP addresses on that interfaces, on router's interfaces. So we have gigabit 00 interface, and we have provided by us IP address is 2001 :1 with prefix 64. Also, we can see here FE80 address and so on. This address belongs to the category of address like a link local address, and is non-routable IP address, and is generated automatically by the router's interface, which is turned on and which is connected to the working port from the other side. And also you can change the link local address if you wish. You can type IP version 6 address FE08 and for example also 111, let us say like this. Our prefix is going to be 64, and then we'll just type here or what, and afterward we'll just type link local. And if we'll take a look one more time for the output interface brief, you may see that now your link local address is this, and your IP address which is provided by you is looking like this. And also it is interesting fact in IP version 6 configuration that you can provide the information about, you can give IP addresses, you can give multiple IP addresses for the single interface on the router's port, so that I can say IP version 6 address 2001 :1 and prefix 64. As you see, this and this two addresses are on separate networks. They are from different networks, but even in this case, you may have this two IP addresses from separate networks on single interface. Like do show IP version 6 interface brief command will show us that we have a multiple IP addresses on the single interface, and it is possible to work with multiple IP addresses. It is very huge advantage of the IP version 6. You will know about disadvantages in next video lessons. And now let's take a look for how we can make the configuration of the loopback interfaces and why they are needed to us. Now it's time to make configuration of the loopback interfaces. What is the loopback interface? Loopback interface is the interfaces is the logical interface on the router, which can be generated. I mean, which can be turned on and which can have an IP address, and you can use this logical interface to make some tests, like by testing your routing protocols. And in future you'll see that one of the dynamic routing protocol, like an OSPF, is actually uses this link locals IP address, loopback interface IP address as the router ID. And now it's time to show you how you can make configuration of this interface. But previously we'll take a look for our output of IP addresses. We see just only this interfaces, and we don't see any loopback interface which is generated because we didn't generate it yet. We have to go to global configuration mode, and in global configuration mode you will just type the command interface, and afterward you will type loopback, and afterward you can type you can create a huge number of the loopback interfaces, as you see here, so that you can create interface loopback 0, or you when you turn when you just press the enter button, you can see that the output shows you that the interface is turned on, so you don't need to turn on by the command like a no shutdown, because it is turned on automatically. Or if you wanna, for example, if you exit from this interface and if you want to penetrate into configuration of loopback interface, you can type the abbreviated form of it, like interface. Instead of writing loopback, you can just type LO and, for example, 0 or 1. Now, our loopback interface of router 1, so let me type here interface LO0 is going to have an IP address of IP version 4 is going to be 1111 with prefix 24, and IP version 6 address is going to be 2001, and let's say 10.1 with prefix 64. So let's realize this idea. We have to just type IP address, and our IP address is going to be as listed in the scenario, and afterward IP version 6 address 2001 10 double colon and 1 with prefix 64. Here it is. So now if we will type command show IP interface brief, you will see that you have loopback interface 0, which you didn't have before, and line protocol and status are up, and its IP address is like this. And if you want to see IP version 6 configuration of this interface, you have to just type command show IP version 6 interface brief, and you will see that it also has the IP version 6 address, including the loop the link local address, which is generated automatically by this interface when it was generated. Now I think that we finished this part, basic configurations of router. Now it's time to move on, and let's take a look for that how router is making its function of the routing. And we have router switching function. What does it mean? It doesn't mean that router is the switch, but the router is making some switching function. Router, as you know, is interconnecting networks between each other, so that if you have such kind of topology, like you have router 1, which is connected from one side to one switch and from another side to another switch, it means that, or even if it is not switch, even if we have third network, and if it is computer A, for example, then we have three separate networks, network 1, network 2, and network 3. Router has a routing table in which router stores information about these networks. For example, if it is network A, B, and C, routers store information. Okay, I got network A, I got network B, and I got network C, which are directly connected to me through interfaces 00, 01, and 02, so that here you will see this information. So, and when router, and when, for example, one computer B will send information to computer A, Then router will receive this information in the packet header. In destination IP address there will be information about network A, so that router will be able to find network A and will be able to find through which interface router 1 has to switch. Router 1 has to resend this information, and this process of the switching from one interface to another one is called actually the hop. Hop, it is translated as the small jump. Why this process is called like this? Because router is working on layer number 3, and IP address is stored in layer number 3. I mean in the packet header. So this is going to be packet header, and here we have the segment. And to see the packet header, router have to make decapsulation of the frame up to layer number 3. And so look, when computer is generating information, it is encapsulated through from layer number 7 to layer number 1. Afterwards, signals are traveling to the router 1. Router 1 makes decapsulation to layer 3 to find the destination IP address, and afterward make the process and resend the information through another interface. Okay, all this process is called the hop. Okay. Alright, now let's take a look for example of routing in process. And in this example we have with you network 1, 2, 3 and 4, and communication will be happening from PC1 to PC2. Also we have IP addresses which are provided here. So, and as you see here, the IP address of PC1 is 110. The IP address of router's interface FA00 is 10.1, and here is 2.1, 2.2, 3.1, 3.2, 4.1 and 4.10. And also at under the IP addresses you may find out the MAC addresses. This is just abbreviation form of MAC address, due to that fact that MAC address consists of 48 bits, and if we will write in this example the full MAC addresses, then it will be not so pretty view of our example. Now we have to take a look for this example. In this example we have with you example that PC2 sends information to PC1 sends information to PC2. And this is the dialog of our PC1. So PC1 think that, okay, I have to send information from IP address 110 to IP address 410. And what will be happening next? I see PC2 is on different network. PC1 understood that PC2 is placed on different network. Due to that fact, PC1 have to send information to default gateway. And so look, because of PC2 is on different network, I will encapsulate the packet and send it to a router on my network, because the router is the default gateway for this computer. And let me find the MAC address of that router. So we see the MAC address of the router 0010, but computer 1, the PC1, is not able to do it without the help of the address resolution protocol. So that address resolution protocol provides the information about this MAC address, which is mapped with the IP address. And in PC1's ARP cache, we already have this MAC address. That is why we will not send the broadcast message to find the MAC address. Alright, now the packet received by router 1, and router 1 has to make decision what to do with this packet. So as you see here, this is our frame which is delivered to router 1. Source MAC address is OA10, this one, and destination MAC address is the MAC address which belongs to router 1's interface. But the IP address belongs to PC2. Okay, because when you make the communication inside the local area, you use the MAC address of the local area network's gateway in case if you are making communication with other networks. And then a frame was sent to me by MAC address this. Let me investigate the further. So router has to find out where to resend this packet. And a router deletes the header of the data link which been delivered before, and the router looks for the routing table and tries to find out the network 40 and found, and the exit interface is selected as the FA01. And now router 1 has to resend this information to router 2, so that router 1 will change the source MAC address to its own MAC address like 0020, and destination MAC address is going to be found by the ARP. ARP say that the MAC address of router 2 is OB31, and now router 1 will resend this information to MAC address OB31, and router 2 will successfully receive it, sorry. And alright, so let's continue. Now router 2 received this frame, and it's investigating what to do next. And due to that fact that we have with you a serial connectivity which is done by the point-to-point, router 2 do not need to send information to the MAC address of the router 3 due to that fact that we don't have MAC addresses on the WAN interfaces, because it is point-to-point network. I mean, yeah, the type of the network is point-to-point. That is why we will send information to the broadcast on layer 2, and our source MAC address is not required due to that fact that as I mentioned before, we don't have in use the MAC addresses. What happens next? Router 3 delivers this packet, the frame, and afterward it's also making the decapsulation till layer number 3 and makes decision where to resend this packet according to the routing table which has router 3. So let's just take a look for this process. So due to the fact that this is Ethernet type of connectivity, we have source and destination MAC addresses. The source MAC address will be OC22, it's MAC address of router's interface FA00, and destination MAC address will be the MAC address of PC2, OB20. And this is how our packet is traveling through the network. And in this situation, we have just only 3 passes, 3 hops from PC1 to PC2. It's time to take a look how router is making decision where to resend the packet. But first of all, we have to also keep in mind that when router receives the signals, router makes decapsulation up to layer 3 due to that fact that the packet header, which consists the destination IP address, is placed on that layer. And then router searches the routing table for a match, and then if this destination network is a directly connected network, I mean if it is directly connected to one of the interfaces, then router looks for the ARP cache, and if there is no MAC address of destination IP address, then router makes an ARP request by the broadcast. In case if it is not directly connected network, router looks for that if it is a remote network or not. If it is a remote network, which is information about which we have in the routing table, then router makes encapsulation of the frame and sends it to the next hop IP address. Next hop, it is next router on the path of this packet. And if it is not listed, if the destination network is not listed in the routing table, then router looks is there is any gateway of the last resort is available. It's like if there is any default gateway. I'm sorry, not default gateway. Is there is any default route? If yes, then router sends information to default route. If router doesn't have default route, and if there is no remote network is listed in the routing table, then the packet will be dropped, and the router will generate an ICMP message with the information that destination host is not reachable, and this message will be directed to the source for that equipment which is generated this communication. Now, router makes decision of the best path by different parameters. I mean routing protocols. So we'll speak with you about the dynamic routing protocols in the next video lessons. So the dynamic routing protocols are making decision of the best path by different parameters, characteristics. One of them, some of them are making decision by the hop count. What does it mean, the hop count? It means that if in pass between point A and point P there is less amount of hops, then it is best pass. But some protocols say that I don't care about hop counts, but I care about the bandwidth. So let's take a look for this example in which we have between router 1 and router 3 56 kilobits per second, and between router 1, router 2, router 2 and router 3 we have by 1.5 megabits per second. So the speed of the T1 is much higher than the speed of the 56 kilobits per second. And in case if your protocol will use as the best path the hop count, your information will be sent from router 1 to router 3 directly. In case when your routing protocol looks for the bandwidth, then your information will travel by the second pass, which will be actually the better one than the previous. Sometimes, not sometimes, almost all of the routing protocols supports the equal cost load balancing. It means that if you have multiple passes with the same costs, which are absolutely same, then routing protocols will direct this packages with the through the different passes with the equal balance. And some of the routing protocols even provide the ability to make unequal cost load balancing. For example, if here you have 56 kilobits per second and here you have 1.5 megabits per second, then a lot of packages will travel by using this way, and just few packages will travel by using this way. It will be unequal cost load balancing. One of the protocol which supports this functionality is EIGRP, Enhanced Inter-Gateway Routing Protocol, which we'll speak about it later. Now let's take a look for the networks which are directly connected to the router and the networks which are not directly connected to the router. When you are configuring router 1 with directly connected networks like network 10.0 and 11.0 and 202.24, then your router immediately learns about this network. In the routing table of this router will have information about 10 network, about 11 network, and about network 200 and 224 with prefix 30, prefix 24, and prefix 24. Additionally, we'll have information about ports which are connecting this, like this, and serial 000 with this networks. So 00, FA00, FA01, and serial 000, for example. Well, and all non-directly connected networks will not be known by router 1 by default. So that is why you have to provide. So you have two variants of what you will do with not directly connected networks, or you will make configuration manually about these networks, about remote networks. It's called the static routing, or you will use the services of the dynamic routing protocols, which will resolve this problem, and routers will share information about their directly connected networks. So in case if you want to see your routing table, you have to type the command show IP route. So let's go back again to our example. So we have router 11, which is connected to switch 0, or maybe let's go to this network which I prepared for you. In this network we have router 1, 2, and 3, and in case, so look what I did, guys, in this laboratory work. I made up configuration of IP addresses on the interface of router 1, router 2, and router 3. I turned on these interfaces and I gave IP addresses. And now let's take a look for the routing table of each router with configured interfaces. And first of all, you have to go to privileged executive mode and type the command show IP interface brief if you want to see the short information about your interfaces, including IP address. And in this small table, we can see gigabit 00, 01, and 02 interfaces with their IP addresses. We also can see here that they are turned on. The status is up, it means that we wrote command no shutdown, and the protocol is up, it means that we have connectivity from this interface. And to take a look for your routing table, you have to type command show IP route, which will show you all networks which are known by router 1, and they are network 10.0.0.0 with prefix 30. It is this network. 192.168.10.0 with prefix 24, and 192.168.20.0 with prefix 24. So we have three networks which are directly connected to router 1. And when you are configuring interface, you turn on interface, you give IP address to that interface, automatically router plays the information about that network to this routing table. And you may find out here that we have some different codes of the different networks, and they are of different IP addresses, and they are. So we have here, after you type it command show IP route, we have L code. It's representing the local. Local means that this is IP address of interface gigabit 00. This is IP address of interface gigabit 01, and this is IP address of interface gigabit 02. And networks which are shown in this routing table, so we can see with code C define it that these networks are directly connected. So C, directly connected network to gigabit 00 network. Interface is right here. Directly connected in network address to interface gigabit 01 is 10.0, and so on. Well, if you want to see only directly connected networks which are connected to your router, you can type the command show IP route, and afterward just write the command connected. Here it is, and you may find out all three networks. And it means that when you are configuring interfaces with IP addresses, and when you turn them on, your routers automatically place the network addresses into routing table. But we also have some issues. So like router 1 doesn't know about network 10.0.0.4 and 30.0 and 40.0. We'll speak about how to introduce the networks for router which are not directly connected to that router. But now let's continue with our presentation. So directly connected networks can be seen like this. So we have C and L codes, which you already know. C, it is connected network, directly connected network, and L, it is representation of the IP address of that interface. Also, we may have remote network, and when you see the remote network, you can see also the code. You may see that network's network address, and afterward here in the brackets, you may find out some values like this, 90, and like this. So the first value is call it administrative distance. Administrative distance, or it can be called just as abbreviated form AD. AD is the priority of route. So let me write here. It is the priority of not route of protocol, which is providing information about this network. We'll speak about it a little bit later right now. And here we have a special value which is called the metric. So as we mentioned before with you, some routing protocols use as a metric hop count. Some of them are using the bandwidth, and so here it is. After what we have via, it is like through which IP address do we have this network connectivity. It's IP address of our neighbor in this case. So like from router 1, we'll contact this IP address to be able to connect to this network. And afterwards, so here we have identifies amount of elapsed time since the network was discovered. So currently you don't need this information because we didn't start to study the EIGRP. And afterward, through which interface? This is our local interface, as you see here, S000. We have connectivity to this network 10.1.1.0 through 226 IP address. Now it's time to speak about static routing and dynamic routing. So how we can provide information about the foreign networks? We are able to say that, okay, router 1, you have this network and this network, which are connected to you not directly. And also you have internet connectivity through this way. And for router 2, we'll say that, okay, you have this network and this network. So all these arrows will require to be configured with separate comments. So it means that separate rows of the comments. And this called static routing. In static routing, we'll provide all information about foreign networks manually. And in case if we will have some changes in the network, then we have to reconfigure our static routing. And whereas dynamic routing says that a router say that, look, I have information about such kind of networks like 10.0 and 11.0, and this information will go from router 1 to router 2. And router 2 by itself will take a look for its own directly connected networks and all other networks which are available for him, and will send information about it to router 1. So they will exchange information about their networks, and in case if something wrong will be in router 1's network 11.0, then router 1 will mention about it to router 2, so that router 2 will understand, oh, okay, now I don't have this network 11.0, and everything will be done automatically. Now let's take a look for the administrative distance, which is defining the priority of the protocol of the network. So the first priority, the lowest priority is 0, and it is the best one. This is the best priority which can be given to the route. You have router 1, and router 1 connects to network, for example, 10000 with prefix 24. Then router 1 will think about this network with priority, with administrative distance as 0. It means that router 1 will believe to this route, okay, instead of believing, instead of trusting a route from router 2 about this network. Maybe router 2 and router 1 are directly connected to the single network, so this is going to be single network like this. And in case when router 2 will propagate information about this network by the dynamic routing protocol, so for example it will say, well, okay, look, I have network 1000 with prefix 24, and administrative distance for this network will be, for example, 90. Okay, and then router 1 will think, all right, I have directly connected network 10.0.0.0 with prefix 24, which has a priority of 0, and another priority is 90. And then router 1 will make decision which path to be which route to be placed on the routing table. And as you see here, the 0 is the best one, and 90 is much worse than the 0. So then router 1 will skip information about this network and will still use the directly connected connectivity. Or maybe there can be situation like you are making static routing. So static routing is much more preferable than the dynamic routings like EIGRP or OSPF or even a RIP. Because when you are configuring static routing is configured by you, and you have to trust yourself more than you trust the dynamic routing protocol. So that in case when we have example like this, router 3, router 4, router 5, and we have a network, a single network, for example, 2000 with prefix 24. And if they are connected like this, and we can say to router 3 that it will have connectivity like this by using this pass, and it's going to be a static route. And from the other side, a routing protocol, dynamic routing protocol, will say, okay, look, I have network 10 2000 with prefix 24, so you can also go like by using this way. Then router 3 will not place information about this route to routing table, but will place only the information about static route. But in case if something wrong will be with the static route, for example, we have damaged this link, then router 3 will be able to use the information which is coming from the dynamic routing protocol and will be able to send information like this. Well, you have to remember these values of the administrative distance, and you have to remember that 0 is the best one and 255 is the worst one. This is the end of today's presentation, which was called routing concepts. I hope that this video been informative for you, and in case if you have some issues with understanding the subject, you may contact me directly through my email address. And our next video lesson will be about the static routing, and it's a very interesting topic. Hope to see you again on that lesson.